Hello everyone. This is the video made to let you know about the books that we have released in the Inorganic Chemistry. It is a set of 3 books, and these 3 books contain some basic units and also advanced units. So here I will be just showing you what are the topics that are present in each of these power books. And before going into the topics that are included in the book, let me just tell you that we have taken a great care while preparing the content. All this content is the original content of our institute. I have done what do you call literature work almost from 20 to 25 standard textbooks, and from that I have taken all this content. Along with that, I have given the multiple choice questions so that the student gets a practice. Also, I have taken many previous years questions, let it be from GATE or CSIR or SET exams or various competitive level examinations. So here I will be just showing it. The quality of the books that we have released is also very good because we have printed it on 70 GSM paper, so the quality will be very good. It will last for a very long period. Maybe you can expect it for about 15 to 20 years also. We have to pay our gratitude to some great scientists. So in the inorganic chemistry we have Raman spectroscopy, though it is a part of physical. Inorganic also we will be discussing, and along with that Werner, who has introduced Werner's theory. Only after Werner's theory, coordination chemistry has gained a lot of momentum. Okay, so just paying a gratitude to these great scientists. Now let us move on to the first book. In the first book we have chemical periodicity, or the periodic table which we call it as, chemical bonding, metallurgy, S block elements, alkali and alkaline earth metals, D block elements and nuclear chemistry, along with multiple choice questions and previous year questions. I will be just showing you a few slides. So what type of material that I have put it. Periodic table, all the regular content you will be finding in almost every text, but here what I have done is I have taken the periodic trends for all the groups. Suppose if I am just showing it for alkali groups, how the ionic radii or how the density, melting points, hydration energy, etc., how they vary, all are present in a single table. This is for group 6. You can see that all the trends are present. These are just a few slides that I have picked up from the power books, power book 1, 2 and 3, so that the students will be getting an idea what type of information that you will be having in these power books. Here you can see that the molecular orbitals have been given for sigma bonding or for pi bonding. All the diagrammatic representations are also given neatly. What is sp mixing, and without sp mixing how the molecular orbital diagram looks, after sp mixing how the molecular orbital diagram looks, both comparisons have been given. And once we take up the homodiatomics or heterodiatomics, what is the bond order of it, whether it is paramagnetic or diamagnetic, and also in GATE and CSR exam questions they will be asking you the molecular term symbol, let it be for oxygen or let it be for boron or any other homo or heterodiatomic. So I have also given the molecular term symbols for all these homodiatomics and heterodiatomics. These are only few examples. Later on in the chemical bonding VSCPR, nearly 60 to 70 examples have been given, and these examples have been given with respect to the steric number, number of sigma, and the lone pairs have been given. And for every example I have given you the structure of electronic as well as molecular geometry. Okay, both geometries we will be having. So you will be finding nearly 60 to 70 examples where all the details have been given. These are just a few more examples. The next topic is metallurgy. Metallurgy, the regular discussions are there. What are the various minerals or ores that are present, and what are the different metallurgical processes have been explained along with the experimental setups that have been provided in the book. Later on, alloys have also been given. The various types of alloys, their combinations have been given. Alkali metals, all the physical and chemical properties of alkali metals have been discussed. So all that goes into basics. You should be knowing what is the trend for oxides or what is the trend for carbonates and so on. So all those trends have been discussed in detail. For alkali metals, just one slide of the chemical reactivity of these alkali metals or the chemical properties. Then we also have alkaline earth metals. For the alkaline earth metals also, the physical and chemical properties have been given along with the multiple choice questions and the previous year questions. Later on we have D block elements. For D block elements, all the properties have been discussed that I have already discussed in the periodic table. Whatever is there in the periodic table, that is being applied for these D block elements, and D block element is very important for examination point of view. Also we have to understand D block elements so that coordination chemistry become easier. So detailed discussion about D block elements has been done. Just a few slides from that D block elements. Electron configuration of a metal and what is the lattice of it. After D block elements we have nuclear chemistry. In the nuclear chemistry, all the different types of nuclides like isotopes, isobars, isodiaphers and so on, all the discussion is there, and about radioactivity discussions are also there with a good number of problems. So all this comprises of power book 1. You also find some disintegration series. Moving to power book 2, this is exclusively for coordination chemistry. Almost complete coordination chemistry you will get it. But for the reaction mechanism of transition metal complexes, you will get every topic of coordination chemistry. I have started from the introduction, and from the introduction later I went to Jorgensen theory, Blomstrand-Jorgensen chain theory. After that chain theory, I have given Werner's theory and various classifications of the ligands, isomerism, Sidgwick's theory, IUPAC nomenclature, which is very important, and for IUPAC nomenclature nearly I have taken maybe 70 to 80 examples, or maybe it will near about 100 examples. Valence bond theory, I have explained the theory and examples have been given. Crystal field theory is discussed in detail about the magnetic properties or the crystal field splitting of various geometries. Nearly 15 geometries have been discussed here. Magnetochemistry, and along with the MCQs and previous year questions. Spinels have also been included. Along with that, molecular orbital theory. Molecular orbital theory is also given in this. And closing the coordination chemistry, stability in metal complexes along with HSAB principle has also been discussed. At the end, I have given a few multiple choice questions that were asked in the previous JEE and NEET questions, and also some revision questions. Just let us look some slides what you will be getting in this book, the second power book. Jorgensen's or Blomstrand-Jorgensen chain theory, different examples. Later on, Werner's theory, the classical example of cobaltamine chloro complexes. Now here for the classification of ligands, generally we discuss only one or two classification of ligands based on strength or based on bonding aspects. But here I have discussed at least 5 to 6 different types of ligand classifications. This is just one of them. Very rarely you will be finding this type of classification. I have included all these things. Coming to the ligands, what is the name of the ligand, what is the structure of that ligand, what is the charge that the ligand bears, all these have been given nearly for about 100 ligands. 100 ligands have been discussed starting from the monodentate up to hexaheptadentate also. After these ligands, isomerism has been discussed. In isomerism, I have given a table. This table will be giving you how many isomers are possible for a given square plane or a octahedral complex. Here I have given it for a square plane complex, and also octahedral complex also you will find. But one different thing that you will be finding in this book is, for each and every possible isomer of octahedra, I have drawn this structure also, so that you will be getting an idea for A what is trans, or for B what is trans, and so on. For each and every possible stereoisomer, I have given all the structures also. Another unique feature is optical activity is present even in the coordination complexes, transition metal complexes. Suppose if say some cobalt complex is existing in a delta form, or it could be existing in a lambda form. So whether the given structure is in delta or whether it is in lambda form, how to convert it and how to get the configuration has also been explained in detail. Here is just one slide related to it. IUPAC nomenclature has been given for plenty of complexes. Here is an example of a slide where different complexes have been given. All these are the beginning complexes where we call it as Rheinicke salt, or the salts which have taken the name of the scientist. Later on, The regular nomenclature have been given, nearly 60 to 70 complexes of this, and about 15 to 20 complexes of the previous ones. So that makes up anywhere around close to 100 IUPAC nomenclatures. For valence bond theory, again complexes have been taken and their oxidation states, hybridization, whether it is inner orbital or outer orbital, and what is the magnetic property of all those complexes. All important complexes have been tabulated. And going to crystal field theory, in the crystal field theory, octahedra and tetrahedral complexes, what are their CFSE values, both in delta O and in dq. In the fractionals also I have given, and what is the pairing energy and exchange energies for each of these configurations has also been provided. Distortions I have discussed in detail. Just an example of a distortion where you find the dynamic Jahn-Teller distortions, or we also call them as Jahn-Teller distortion. Well, I said splitting patterns. There are plenty of splitting patterns. I've just taken one example of a distorted tetrahedral complex and how the splitting goes. All this have been explained here. Orbital angular momentum, the magnetic momentum or the magnetic properties have been explained, and after the magnetic properties, orbital angular momentum table has also been provided both for octahedra as well as tetrahedra. Well, later discussion, this is about the molecular orbital theory. Just a second. Yeah, this is about the molecular orbital theory, and in the molecular orbital theory, constructive and destructive overlapping explanation. Along with this, I've given some orbital overlapping interactions so that you will be understanding the LGOs, ligand group orbitals, how do they form. Detailed molecular orbital diagrams have been given for square plane, octahedra as well as tetrahedra, both for sigma as well as pi bonding. So you can look at the pi molecular orbital diagram also. There is a difference between a sigma and a pi. Lot of interactions and lot of molecular orbitals. And in the appendix, I have given the IUPAC geometries. How should we name it? How should we name it in the sense? Suppose if I take trigonal bipyramidal, generally we will be discussing in the regular classes like TBP, but TBP is not a standard abbreviation. We have to call it as TBPY phi. So for each and every geometry, what is the IUPAC abbreviation also has been given in the appendix. Coming to the Power Book 3 or the third set of the book, here I have included two important topics, advanced level topics of CSR and GATE. One is bioinorganic chemistry and the second one is symmetry. Third one is group theory. So altogether 3 different units have been clubbed in this book. In bioinorganic chemistry, in the beginning I have given some introduction. Later the introduction, I have taken all the oxygen binding proteins, hemoglobin, myoglobin, both the deoxy and oxy forms, hemerythrin and hemocyanin, deoxy and oxy forms. After oxygen binding proteins, we have electron transfer proteins. In the electron transfer proteins, I have discussed about ferredoxins, cupridoxins and cytochromes, followed by electron transfer proteins, the electron transfer proteins, ferredoxins, cupridoxins, and followed by photosynthesis. So photosynthesis also we will be getting some important questions. After photosynthesis, I have discussed about a few metalloenzymes, which is the third most important part of bioinorganic chemistry. First part being the oxygen binding proteins, second part being the electron transfer proteins, and third part being the metalloenzymes. Photosynthesis is an additional topic in bioinorganic chemistry. Some additional information has also been provided related to bioinorganic chemistry, and at the end, previous year questions and also MCQs have been provided. Symmetry and group theory, I will be just showing a few slides. Now here is the bioinorganic, just a few slides I am sharing so that you will understand what type of subject is present or the content. Different bonding modes of dioxin has been provided so that you will be getting an idea about dioxygen, and once you are aware of dioxin, then you can easily understand the bonding aspects between the hemoglobin, myoglobin or hemerythrin and also hemocyanin. Different biomolecules are available, but the most common ones that we get is porphin, chlorine, corrin and corphin, but in this case mostly porphin will be discussed because it is present in hemoglobin and also in some cytochromes. Here is a slide which will be projecting the geometrical aspects of deoxy hemoglobin, and the details have been shared in such a way that the distance between the plane of the porphyrin and the nitrogen of imidazole of histidine has also been provided, because in some of the GATE and CSR exam questions, such questions are also being asked. What is the distance between the plane of the porphyrin and the nitrogen of fumidazole of histidine? This is again the geometrical aspect. In this case, I am providing the oxyhemoglobin and how the hydrogen bond is formed by the distal histidine stabilization, and all the details have been provided. After this, we have oxygen adsorption isotherm. I am taking 4 variables. One variable is fetal or mother hemoglobin is one variable. Second variable is a pH. Third variable is temperature, and fourth variable is carbon dioxide. Here I have just shown only 2 oxygen adsorption isotherms. For hemocyanin, deoxy and oxyhemocyanins have been explained, but this is the detailed structure of oxyhemocyanin which you rarely find, because in this case each copper is present around a square pyramid geometry where the apical bond will be longer, the basal bonds will be shorter. So all such details have been included in the content. I am telling you, this is a very standard content which you will find it in the most standard textbooks and also some research articles. Directly you can see that in the previous CSR exam questions they have asked what is the bonding nature of dioxygen in hemocyanin. So how does it get neta 2 neta 2? All the detailed explanation has been provided. Instead of directly giving it is neta 2 neta 2, how are you getting that neta 2 neta 2 and how it is becoming diamagnetic due to antiferromagnetic coupling? All that process has also been explained. When we move to the electron transfer proteins, in the electron transfer proteins, respiratory chain has been given, and directly from this chain you can see many questions in the previous CSR exams or even in the GATE exams. Just a slide for cytochrome. Theory I have not shared, I am just sharing a few important slides so that you will be getting an information about the content. Ferredoxins starting from rubredoxin 1 iron, 2 iron, 3 iron and also 4 iron ferredoxins have been discussed. This is just one structure for 2 iron ferredoxin. Cupridoxin is just a few examples of cupridoxins and their different structures and what is the axial ligand that has also been provided here. Coming to the photosynthesis, oxygen evolving complex, what is the structure of oxygen evolving complex? What are the metals that are present? That was a previous exam question. So in detail, how many manganese and how many calcium that are present, where are they distributed? Even that details have been provided in the oxygen evolving complex. Here it is a copper. These come under the metalloenzymes, copper zinc superoxide dismutases. What are the structures and what are the functions? This is a nitrogenase, the structure of nitrogenase. Well, moving to the next unit, symmetry. A great care has been taken to explain the symmetry because very few materials are available in the market where you will find the full details about symmetry and group theory. But here I have given a very comprehensive explanation about the symmetry as well as group theory, which once if you can understand, you can very easily attempt all the CSR and even GATE exam questions related to group theory as well as symmetry. You can easily score 4 marks in part C of CSR also. What are the various types of symmetry elements? What are the stereographs for rotational axis have also been provided. So once you are aware of these stereographs, you can understand the types of rotational axes that are present in a given molecule. Well, whenever we go to rotational axis or some planes, we have different explanations. So here what I have done is I have taken the projections in such a way that you can very easily understand the planes that are present and what are the rotational axes also that are present. Newman projections have also been taken. This is one more important understanding where how the coordinates are shifting when I pass the imaginary rotational axis or the planes or the inversion. So all such details have also been discussed with respect to the Cartesian coordinates. Just I am putting forward only 2 slides here, but I have given plenty of such examples where when I start with a coordinate upon operating some symmetry operation, how does it change, and a multiple operation. Suppose if I go from maybe I'll take a sigma xz followed by sigma yz, or maybe I'll take a C2 along Z followed by sigma xy, or C2 along Z followed by sigma xz. All that combinations and what is the final result has also been provided. Once you are aware of this Cartesian coordinate shift while I operate different symmetry elements, very easily you can also understand the molecules, how they shift their atoms when I pass these symmetry operations. or the symmetry elements. Platonic solids have also been discussed: tetrahedra, octahedra cube, icosahedra and dodecahedra, and there is a beautiful correlation given for these Platonic solids related to the element which was related by the philosopher Plato. I am just showing one slide. Here I have given all the symmetry elements and where are they passing from. Where are they passing from? Because in octahedra there are 48 symmetry elements, and if I just show a polyhedra, it is very difficult for the student to understand where is the rotational axis passing from. But all that content has been explained and it has been tabulated so that you can very easily understand where the element is passing from and how should you proceed from. So this is like a supplement for the classroom teachings. Later on, point group table has been given. This is just one example. I have started right from C1. What is the point group? How many number of symmetry elements are present in them? What are they? That table has been given. Starting from C1 up to icosahedra. So starting from symmetry element 1 order to 120. Well, moving from symmetry, group theory, character tables. Character tables have been provided and I have explained in detail about the character table. What are the characters? What are linear functions and rotations, quadratic functions? Everything has been given in detail. I can definitely bet you will not get this much of details in any other standard material. The 4 important rules: dimensionality, characters, orthogonality, all those rules have been given with respect to some point group, so that you will be knowing how to work out on your own whenever a point group is given to you. Matrix representations is also an important question at CSR level. Though if it is not a question, you have to understand the concept. And the concept has been provided in detail about the matrices, and these matrices have been applied to derive a particular character table. Suppose I take a C2V, or I may take a C3V, C2H, or any other small point group. I can derive all the characters or most of the characters just on the basis of matrices. So that detailed derivation has also been given, and also matrices have been provided for each and every symmetry element. So that in the GATE exam also you will be finding they will be giving you a matrix. They will be giving you some x and y. What is the value of x? What is the value of y? So you can very easily understand whenever you go through this concept. You can easily attempt all such questions. Direct product is one of the most important topics of group theory. And once you are aware of direct product, you can attempt some 4 marks question at CSIR, where they will be asking which of the following transition is an allowed transition or a forbidden transition. So to say whether a transition is allowed or forbidden, you should have an idea about direct products. So I have taken plenty of point groups, and in detail I have worked out each and every direct product within a table, and I have compiled it into a larger table, so that every smaller table you will be finding at once. Later on, another question that you can expect is about the vibrational modes. So one question they ask is about how many vibrational modes are present in pyridine, or how many IR active vibrational modes are present in pyridine. That was a previous CSR exam question asked for 4 marks. So I have given plenty of examples worked out in detail to explain how many vibrational modes are present, of which how many are, what are the total number of modes, of which are rotations and vibrations, which are translations. After I subtract rotations and translations, how many vibrational modes do I get? Of the vibrational modes which we got, of which IR active vibrational modes and Raman active vibrational modes, everything has been discussed in detail. Another such example of Cu2 Cl2-, where is the rotational axis passing from, inversion and plane, all of them have been given in detail. Then we have to work out the number of unshifted atoms, which is a method. That number of unshifted atoms is multiplied with the character of that particular matrix, and we can derive a reducible representation. Once I get a reducible representation, we break it into irreducible ones by using standard reduction formula. All the reductions have also been given in detail. I have given plenty of examples. Some of the answers that I have given, some have been given as an assignment so that you can work out. Just a few examples that you can see. And also I have given some reference from where I have taken all those things from a research article. And to close with the symmetry and group theory, I have given some of the symmetrical structures that are present. Plenty of structures have been given, but just for our understanding, I have shared only a few of them. Okay, so this is all about our new material which is available for the purchase. It will be a set of 3 books. Power Book 1, 2 and 3, and what are the topics that are present in it also I have discussed. And again I'm repeating, this is a very standard content that I have written, and also it has been printed on a very good paper. You will be just loving the quality of the paper and also the print quality. Thank you.